might be going. Yes, I think it's going. Okay, so to circumscribe a polygon about a circle, you have to start with the circle and then you draw the polygon around the circle. Each of the sides is tangent to the circle. So here we start with the circle. Circum means around, it's not inside. Circum, we're going to draw the polygon around the circle. Circum means around the outside. So my polygon is going to be drawn with each of the sides tangent to the circle. That's one of the sides. There's another side. There's another side. I could actually make this be a triangle by making those sides join, right? But I'm going to do a quadrilateral, which means my fourth side has to be drawn in there, so it can be drawn tangent to the circle. That's circumscribing a polygon about the circle. Now, to inscribe a polygon in a circle, inscribe a circle in a polygon, notice we would have to start with the polygon. And then we're inscribing the circle. So then, draw the circle inside the polygon. The circle must be tangent to each of the sides of the polygon. So we have to start with the polygon. We're going to start with a triangle. And then we're going to inscribe the circle. Francis, what do you think the circle is going to look like if I inscribe it in this polygon? Inscribe. What does that mean?
It's going to be inside.
Inside, yes. So inscribing a circle in the polygon, and it has to be tangent to all of the sides. Okay. Now we have a common tangent type vocabulary, yes. We are on page 334. Thank you. Forgot to answer your question. So common tangents. Are lines that are tangent to more than one circle. Now, if I have two circles, we can talk about two different types of common tangents. We have common tangents that are externally tangent, and we have common tangents that are internally tangent to these circles. An external tangent would be a line like this, where it is tangent to both circles. I can get it so it's tangent to both circles here. That's as close as I can get it. But if you look at the centers of the circles and a line that connects them, that tangent does not cross that line. So it's called externally tangent to the two circles. Is there another external tangent? So the other external tangent on the bottom would look like that. These are both external tangents. Now, if I have internal tangents, they will cross the line that connects the centers. So, what would an internal tangent that's a common tangent look like for these two circles? Let's see if I can draw one the first time. There's an internal tangent. Is there another internal tangent I can draw?
Yeah.
The other direction. Okay. Let's see if I can get that one. Those two are common internal tangents. Okay. Circles can be tangent to each other. Circles can be internally tangent or externally tangent. If they are tangent, they intersect at exactly one point, and probably you can kind of picture what they would look like. I'm not seeing it. Anyway, tangent circles. If they are externally tangent, then they are not one inside the other. So this would be one of the circles, this would be the other. They are tangent to each other because they intersect at exactly one point. Try to put that center where it should be, and my board's not exactly aligned, so we'll just leave it. Now, internally tangent. The one circle is inside the other. Those are internally tangent circles.
Oh.
So now, the question might be, thinking common tangents. Are there common tangents to these externally tangent circles? Yes, this would be a common tangent.
Or direct out though.
Yep. This one's an external tangent. We could draw the one Dustin said. What would we be drawing if we draw the one that goes down the middle? Is it an external or an internal tangent? This one crosses a line that joins the center, so it's called internal. The green one is external. The circles are externally tangent, yes. But now talk about the lines. The lines are common tangents. This red line crosses the line that joins the centers, so it fits this diagram. Okay, so then the question would be, is there a common tangent to these two circles? Yes, just one down the side. And the question would be then, is that an external or an internal?
The external, so they don't cross that line.
Exactly. when you draw the line that joins the centers, it's impossible to cross that line. This is an external tangent.
What's a common X?
Externally tangent circles, but with common tangent lines.
It's almost like that one.
These two circles are not tangent to each other over here, but they have external tangents drawn. These two circles are tangent to each other and have two external tangent lines as well. But how many internal tangent lines? One common internal tangent. Yes. These two circles are tangent to each other internally, but there's only one common tangent, and it's an external tangent. All right. I think I have covered the vocabulary.